This video is on the objective calculate and interpret the confidence interval for a population mean with a known standard deviation, right? Sigma is known, using the calculator. So I did one video like this before. This is number 2 on a second question from your Newton Alta homework related to this objective. It's pretty simple, so this should be pretty quick if you saw the first one. So again, if you're unfamiliar with how they're using the calculator, how they're going about this objective, please look at more instruction, alright, and see how they're doing things. Hopefully it helps. So here, suppose finishing time for cyclists in a race. Finishing times are normally distributed and have a known population standard deviation of 6 minutes, so that's sigma. Sigma's known, right? Known standard deviation. And an unknown population mean. A random sample of 18 cyclists, there's n, right, your 18 cyclists, the sample size is taken, and gives a sample mean of 146 minutes, there's your x bar, right. Use a calculator to find the confidence interval for the population mean with 99% confidence level. So there's your confidence level. Now, remember, you're going to have to enter this as a decimal. 99% is 0.99 on your calculator. And round things to 2 decimal places. So all they're asking for is the interval here. Again, real easy. When you're estimating a mean, you go stat, over to tests, down to number 7. Right, when you're estimating a single mean like we are here, we're estimating one population mean, and the population standard deviation, that sigma, is known. Right, if it's not known, then you can't use this. But since it is known, I can go just z interval. And again, do I have a list of data? No. Again, if you had a list of data, you'd have to enter the data, go stat, edit, and enter the list of data, and then use that list. Right, if I went to data here, and I'd have to enter this list here, and if there was a frequency list also, but we're not given that here. We're just given statistics. So I go over to highlight stats, and then enter the pertinent information. What is the sigma? Well, they told us the population standard deviation was 6 minutes, right? So 6. What was the x bar? They said the sample mean was for that sample was 146 minutes, so 146. And then n, what was the sample size? 18 cyclists. And then the confidence level, the C level, was 99%, so I enter that as 0.99. 0.99, and then calculate. And there we go. So to estimate that unknown population mean, we're 99% confident that the mean for the population, right, the mean finishing time for all cyclists, is somewhere between 142.36 and 149.64 minutes. Done. Right? And those are already rounded seemingly to 2 decimal places, so that's what I'll enter. The lower limit on this interval is 142.36. The upper limit to 2 decimal places already to 2, 149.64. And that seems to be it. Very quick and easy. And again, if you've done this, you can then, if they asked you, you can give me the margin of error. Remember, when you have a confidence interval, the distance from the lower end to the high end is 2 margins of error. So if I subtract these and then divide by 2, there's your margin of error. And also make sure that the mean, the sample mean, is exactly halfway in between, 146. 146 is exactly halfway between these two, as it should be. And then we can find the margin of error that way, right? What's 146? 146 to 149.64, that's 3.64. So the margin of error is 3.64 minutes. So if you were asked for the margin of error, you could also do that pretty easily. Great, that's correct. They tell you go to the z interval thing, do exactly what I showed you there. And I don't think there's a second part to this problem. No, there isn't. And then all the problems related to this objective are the same. Right, you just have to know what sigma is, what x bar is, what n is, and what's the confidence level. And just make sure you enter the confidence level as a decimal. All right, so again, pretty easy, pretty quick. Should be no problem. And thank you for watching.